Okay, let's talk about electron configuration in atoms. So as we know, in every atom we have a nucleus, which is comprised of protons and neutrons. So we have protons and neutrons in the nucleus, which make up most of the mass of the atom. Then around the nucleus we have electrons that are orbiting around the nucleus. Now each electron has a negative charge and each proton has a positive charge, while the neutron is neutral, which means it has no charge. Now, we want to find out a way to figure out how each electron orbits each atom in the ground state. So, for every orbital around the nucleus, we have a shell. So, in the first shell, we can hold 2 electrons because it has one orbital and one subshell. Now, we have the second shell around the nucleus. Let me draw a better picture. So here's our nucleus right here. We have our first shell, which can hold 2 electrons. We have our second shell, which can hold a maximum of 8 electrons. And we have our third shell, which can hold a max of 18 electrons. And then the shells go on and on. Now, let's find a way to figure out how the shells and subshells and orbitals work. So, in our first shell, we have one subshell, which is the S subshell. And in the S subshell, we have one S subshell, which means we have one orbital. And for every orbital, we can hold up to 2 electrons. Now, in our second subshell, we have the S subshell, the 2S subshell, and we have one of those, and then we have 3 of the 2p orbitals, or the p subshell. In the third one, we have the 3s subshell, we have one of those. We have 3p subshell, we have 3 of those, and then we have the 3d subshell, and we have 5 of those. As you can see here, we have in the second shell, we have one of the 2s, and then we have 3 of the 2p shells, which means we have a total of 4 orbitals, and then in the third shell, we have a total of 9 orbitals, and in the first shell, we have a total of 1 orbital. As you can see, we formed a pattern here. For every shell, we have n subshells. So, for example, for the first subshell, we have 1 subshell. For the second one, we have 2 subshells. And for the third one, we have 3 subshells. And for the number of orbitals, we have n squared orbitals per shell. So for the first one, we have 1 squared, which is 1 orbital. The second one, we have 4 orbitals because it's 2 squared, and 3 is 3 squared, so we have 9 orbitals in the third shell, and then so on. Now, how do we fill up the orbitals in the ground state? So, for every atom, we would fill up the 1s orbital first, which is the lowest energy, and then the 2s, then the 2p, then the 3s, then the 3p. Then we would move on to the 4s, and then the 3d, even though 3d is closer to the nucleus because the 4s has a lower energy than the 3d subshell. Now, let's do an example. Say you have an element for element 11, let's say, and you want to find the electron configuration for element 11. Well, we know that if it's element 11, it must have 11 electrons. And we know that the first 2 electrons in the ground state, or this is the question is asking if the electron configuration for the ground state of element 11. Now, if they're asking you for the ground state of element 11, we know that the first 2 electrons must be in the first shell of orbital s. So 1s, 2, that's the form you have to write it in, which means that 2 electrons are in orbital 1, shell 1 orbital s, which means the 1s2 is full. Now we have 9 more electrons to take care of. Now, what comes after that is a 2s subshell, and there's one of those, which means that the 2s can hold a maximum of 2 electrons, so we have 4 electrons that are filled total. Now we have 7 left. Now, I said there was a total of 3 of the 2p orbitals, which means that we have 7 more to take care of, and then in the 2p orbitals we can fit 6 electrons. So all of them get filled, so we have 2p6, and then we have 1 more electron left. That would go into the 3s orbital. So we'd have 3s1, and then that sums up a total of 11 electrons in the ground state. And this would be your final answer. So you would continue to use that pattern for every element as you go along. You'd keep filling the lower energy orbitals until you get to the higher ones, and you'd make sure each one is filled before you move on to the next one, except in the case of 4s and 3d here, where 4s comes before 3d because the energy level of 4s is below the energy level of 3d.